This is section 9.4, using a system but writing it into a matrix. A matrix is just an array of numbers in a square or rectangular format. So the whole things that you can read about. Here, this top picture is transforming from a linear system to a matrix. The difference between a system and a matrix is there's just no variables. No variables, no equal signs, and no plus signs. If it is negative, you keep your negative. So if I write this system is a matrix, my first row would say 7, -2, -1, and a 4. And then for the next row would be a 1, a 0, because there's no y term, 3, then a 6. And the last row would say 0, 4, 1, 7. And here is the matrix. You can use the same operations that you use to solve systems as you can with matrices. So we're going to do this one as a matrix. This will probably be the only one I actually do. So I'm going to write it as a matrix first. 1, 1, 4 for the first column. Remember, columns go up and down, rows go across. -1, 2, -1 for the next one. 5, -6, 8 for the third one, and then 3, 7, 15 for the last one. So I still want to get rid of this 4. That is the first spot I still want to get rid of. So I'm going to multiply -4 times row 1, add it to row 3. So I get 1, 1, 0. -4 times -1 plus -1 is 3. 5, -6. And then -4 times 5 plus 8 is -12. -4 times 3 plus 15 is 3. Then I want to get rid of the 1. That's the next spot. So I'm going to do negative row 1 add to row 2. That's a plus sign. So 1, 0, 0. So -1 plus 2 is 3. -5 plus -6 is -11. And -3 plus 7 is 4. And then next would be to get rid of this bottom 3. So I'm going to do negative row 2 added to row 3. 1, 0, 0. -1, 3, 0. 5, -11. So -11 plus 12. -12 is -1. And then -4 plus 3 is -1. What this is saying right here is that -z equals -1. Line positive, so z equals 1. Now I can back substitute. So what the second row says is 3y minus 11 times my z, which is 1, equals 4. 3y is 15. Y is 5. And then what the first row says is x minus y, which our y is 5, plus 5 times z, which is 5 still, equals 3. Those 5's go away, so x is 3. So the answer is 3, 5, 1. Which it does say, right, if this is dependent or inconsistent. Dependent, we are going to say, because there is actually an answer. Then it talks about row echelon and reduced row echelon form. I'm just going to go down the pictures, just so you know what they look like. Row echelon forms, you have ones that lead every row, unless it's all zeros. Reduced row echelon form is ones that lead every row, and then there's zeros behind them. That's what it looks like. I'll never ask you to solve them so they look like this by hand, but our calculator does them in that version. But just so you know what they look like. So that tells you all the things of how to get it that way. Here is the next example, which Gaussian elimination is the stuff that we just did to get in row echelon form. And then use back substitution. This answer is -10, 5, -2. You can work on that on your own. And it has an example, or it tells you ways to get it into reduced row echelon form, which I will not ask you for. You can just get it to the way we need it and then use back substitution. This one, however, says using Gaussian Jordan. We're not. We're going to use our calculator. Graphing calculator, so I can tell you what it looks like. But I do need to put this in a matrix first. So 6, 5, -3, 18, 15, 1, -6, 3, 33, 24, -20, -42. So we need to bring the calculator up. Above the x to the -1 key says matrix. So that's what you're going to hit, and this menu appears. You want to go into the first matrix, but you want to go over under Edit. So under Edit, we want to edit Matrix A. Then it's going to ask how big it is. Oh, I forgot to talk about this. Well, our matrix that we want, it goes rows by columns. So we want 3 rows, because we have three equations, with 4 rows. The 3 variables plus what they equal. So we want a 3 by 4. I forgot to mention that in the beginning. And now I just need to type in my numbers. So I have 6, 18, -6, 24 for the first row. The next row goes 5, 15, 3, -20. And then the last row goes -3, 1, 33, and -42. Now I have all my numbers inside my row. And if you notice here in the bottom corner of your actual screen, it tells you what row and what column position you are in. So I'm going to second quit out of there, go back to my regular screen. But I have to go back into Matrix. So I'm going to go back into Matrix. This time I'm going to go over to Math. And I'm going to go all the way down to, where is it? There we go. Those two right there, A and B. A, this A part, stands for row echelon form, which means it'll put zeros on, or ones down the main diagonal and zeros underneath it. So you can use back substitution. But if you're checking your calculator, using your calculator to check it, you want to use B, not A. B is reduced row echelon form, which means it'll put ones along the diagonal, zeros everywhere else except for the answers, which means the first row is the X, the second row is the Y, the third row is the Z. So I want to select B. Remember that we put all our stuff into Matrix A, so I have to go back into Matrix, and under Names, grab Matrix A, and hit Enter. This is X, Y, Z. So X is equal to 37, Y is equal to 12, and Z is -5. And that would be the answer for this next one. -37, 12, -5. You do have a system on the final exam. You will have the option to solve it with the X, Y's, and Z's, or to put it in a matrix and solve it with the matrix, or there's a third way that we will learn, which is called Kramer's rule at the end of this chapter. And onward we go. Here it shows the different ways that you can show you cannot on the final exam choose your graphing calculator. You can use it to check, but not to actually show the work to solve. Many of these It's the same exact method as we've been doing. So this is no solution, obviously, since it says a system with no solution. That one's no solution. This one is infinite. So you actually end up getting like a 0 equals 0 or a 10 equals 10 at the end. I'm not sure what it is. So this is where you set z equal to t and back substitute. So the actual answer for this one is 7t minus 4, 4t plus 1, and then a t. This next one, this b, don't worry about. We're not doing 4 variables. There's no way. But we will do this word problem. So we have this nutritionist performing an experiment on student volunteers. He wants to feed them a daily diet, and it includes this stuff. I'm not going to read this all to you. So we have, this is the part that we need. That's what they need to consume every day. Okay, so they need, this has to equal 310, this has to equal 77, and this has to equal 1520. So actually that right there is our matrix. So this is like X, Y, Z, and this you would solve. We can plug this into our calculator. Again, for anything like that's graded, make sure that you actually do the work. Don't just put in the calculator because that will not count. So I'm going to go back into matrix, but just to practice using our calculator, we can do it in here this time, just this once. Remember, we are doing 3 by 4s for our matrices, how big they are. And the first one is 25, 75, 10, 310, 8, 15, 2, 77. And the last row, 130, 100, 70, and 1520. So we're going to second quit out of there. Come in my regular screen. Remember, I put in B now. So I'm going to go back into matrix, go over to math, go all the way down to edit. Oh, I want B, RREF. Go back into matrix. This time I'm going to select B right off whatever that menu was. Names. Enter. Here's my X, my Y, my Z. Well, this isn't really there. So X is 5, Y is 1, Z is 11. So I need 5, I don't know what's the ounces. I need 5 ounces of mini-cal, 1 ounce of slow starve, and 11 ounces of slim quick. Sounds delicious. All right, and that is the end of this section.